So good morning, everybody. My name is Vishnu Dutt, and in today's session, we are going to learn some cool stuff, right? And to let you know that yesterday session was only 1.5 hour session, and the reason was I got some personal emergency, and that is why I couldn't take the remaining 1.5 or 2 hour session. But that is perfectly fine. We will be covering it. So today, whatever is left, we are going to cover with some more cool stuff, right? So here is the thing. What is the agenda of today's session? But before the agenda, I would like to tell you that the questions are pretty less, although people are asking some cool questions, uh, and I can understand because this is just the beginning. But whatever comes to your mind, just ask. Even if this heart-shaped structure, whatever I have drawn here, right? If that doesn't make sense, just ask why you have drawn this heart, right? To answer this, basically this networking or specifically these a Cisco certified network associate exam, which I passed, I think many years back, right? So when I read a networking, it was very close to me. It is very close to me, and that is why basically I put this art structure. So the overall point is, if you do not get anything, please do ask, right? How, whether it's relevant or irrelevant doesn't matter. If it is totally irrelevant, I will be letting you know, right? Otherwise, I would be answering it for sure. Okay. So here are the characters Anjali and Rahul, and only prerequisite for this complete course was curiosity, and these two characters are curious and they are talking, right? And they were saying that yesterday when I was going through the class of Vishnu, right? He was mentioning that on a particular board, if you get only 5%, that is more than enough. Is that true? Rahul is answering that I'm not sure about it, but I didn't get answer of some of the question, pretty convincing answer, right? And that is why I mentioned that in yesterday class, if you get 5% of the board, whatever I was explaining, that is going to be okay, right? But that was not an answer which I would like to give, right? So we will be starting once again, not the complete yesterday session, but there were some gaps, right? There were some gaps. When you were asking question, I was not able to explain it the way I generally do. Okay, so we will be guiding through one. We will be talking once again that how message is going to send over TCP/IP in over a different diagram this time, right? So that the clarity may be from this 5% to maybe 50%. Let's see. Let's see that. So this is the first point of agenda, today's agenda, right? Yesterday, I couldn't keep my promise that I will be covering all those things. But yes, today, if you give me your next 2 to 3 hours, you are going to learn some cool stuff. First thing first, how the message is flowing over the TCP/IP model. But we are going to learn in a different way this time, right? Then we left yesterday from where to start. We all know that the TCP/IP inventors divided the problem into 5 different layers, and we were pretty confused from where to start. There are so many things to learn, and we have decided that we are going to learn from the network layer. Then we are going to talk about network layer in detail, and you all know that the most important thing there is the IP address. We will be talking about it, and the most of the today's class is going to be understanding the IP address and its structure. Many people says that they find difficult subnetting, right? Although the mathematics is very simple, but they do not understand why we are doing subnetting. We will be talking about it. Do not worry, right? And if I have that address, right? If I had the normal address, whatever my house address, that is so intuitive, so logical that anybody can read the address and they can come to know that this guy lives here, right? Then whatever the IP address or addressing we are going to read or learn in networking, can someone forward the message on the basis of that? Because we know that postman can forward the message on the basis of the house addressing, right? Can somebody here in the networking deliver or forward message on the basis of IP address? We will be seeing that the device name is going to be the router. We are going to introduce routers, right? How does a typical router look? How you are going to connect to routers, using the interfaces of cable, everything we are going to, and this is absolutely from scratch, guys, right? If you do not have seen router, if you do not have any idea about router or anything, right, you are at the right place. So this is the agenda for the next 2 to 3 hours, and this is my promise, right? Having said that, let's move to our first board right here, which says, let's send the message again, right? And I was talking to you guys over the WebEx, and I was saying, and I wrote a statement there that there is a surprise for Sanya, right? Sanya Sachdeva, and she asked a very good question, and believe me, because of that, I have to come up with this different kind of structure so that you understand, right? There was a question from Sanya that she was saying that network layer provides the IP address, right? We all know about it, right? There is an application layer. If I talk about TCP/IP model, there is application layer, then we have below it transport layer, then the network layer, and then the data link layer. We all know about it, right? And then the physical layer. And she was asking that if the message is coming from the application and if network layer was providing the IP address, then how come transport layer can communicate to the transport layer at the destination, right? It was a great question. I couldn't answer it convincingly because I didn't have this diagram at that point of time. So I thought this diagram and it is going to make more sense. So basically your TCP IP layering is like this from top to bottom, right? But I have drawn it somewhat different way. So what is happening here, guys? The aim is going to be same. We have laptop A. I haven't drawn laptop B. That is perfectly fine. So this is my source, right? And the source name is suppose A. This is my laptop A. And you all know that if it can talk to internet, TCP model is right there into this laptop. It is as simple as that, right? If I say TCP IP model is there, I am saying that these 5 layers have been implemented in this laptop. It is as simple as that. And if I talk about application layer, as I mentioned, it is responsible for human interaction. It is responsible for running some of the cool applications like Google Chrome. You all go onto this Google Chrome and browse different websites. Maybe you have installed the WhatsApp application. It might be the case that the overall working of these applications is quite slightly different than what we are going to see here, but that is fine. We are we are understanding the mind of people who have developed this internet in 1970s time, right? There were no such application at that point of time. But yes, I'm talking about this laptop A in current generation laptop. It is having WhatsApp application, it is having Chrome application, and this is your way to interact with this machine because you write something on the WhatsApp, you write some URL on the Chrome so that you can get access to the internet or you can send message to somebody else through WhatsApp. It is as simple as that. So application layer, I have drawn 2 different application. Number 1 is WhatsApp. Number 2 is Chrome. And believe me, if you get any doubt anywhere over this communication, please do ask because this is going to be your base. And if that is solid, you can be rock solid in front of customer. Otherwise, there is a problem. So whatever comes to your mind, please do ask either by writing the question or straight away raise your hand. I would love to answer in that way too. Having said that, we have this computer two applications, and suppose we have Anjali here, and Anjali has opened this WhatsApp application and she has written, "Hi, how are you?" Believe me, computer is not going to understand what is the meaning of "Hi, how are you," right? For computer, or it is actually the string of 1 and zeros, right? There is a specific way. For example, if you see a character inside a computer which is A, computer doesn't see this as A, right? It sees it is a string of character. I'm not sure how basically this is decoded in ASCII character. But if you open the internet and find the ASCII conversion of A, you will be seeing that there are some bits written uh, along with A. It means that computer doesn't see A as A, it sees A as the string of ones and zero because it understands ones and zero. It is as simple as that. So if you write hi, how are you? If Anjali is writing hi, how are you? And she wants to send it to Mr. Rahul. She has opened this application, written this simple words, hi, how are you? Computer is understanding them as zeros and ones. It is there at the application layer. Application layer has created this data, right? And actually, this data is going towards the transport layer. So here I have the transport layer. Transport layer, presume that it has the buckets, right? Different buckets. So whatever application layer is saying that whatever the data, and it could be a huge data. Right now you are maybe saying, hi, how are you? Maybe you would have sent a complete file, a 3 GB file, a movie to Mr. Rahul, right? If that is the case, then this data is huge. This is a continuous stream, just like if you open a tap, there is a continuous stream of water. The bits are flowing from applications to transport layer like this. It is as simple as that, right? And the application layer, whatever you are sending, transport layer is collecting them on a bucket. Interesting. And WhatsApp application says that this is for Mr. Rahul, and Rahul lives somewhere in, say, Delhi. It is as simple as that. So what is this Rahul? Rahul, and maybe if I go a little bit closer to actually how it happens, so WhatsApp application is saying that this message is for WhatsApp and should go to Delhi. It is as simple as that. And Delhi means address. So we will be deciding address. So to your answer question, to your question, Sanya, actually WhatsApp application is sending the string or the stream of information. It contains maybe huge strings, right? For all that string, WhatsApp application is saying that this is the data from the WhatsApp application. It should go to Delhi. So this is my address. This is the actually application where it is going to be there, right? At the destination. It is as simple as that. So in computer networking, we will be seeing that this Delhi, which I am saying address, this is your IP address, and this WhatsApp application is going to convert as a port. Port means, right? Every application runs on a particular or you can say logical interface, which is actually the port. So WhatsApp application can be called as the port, and Delhi, which is an address, and can be called as the IP address. So this bucket, whatever is collecting the data, it knows that this data is for WhatsApp application and should go to the address XYZ, right? But transport layer doesn't care about the address. It cares about that whether the destination is there or not. And it also says that whatever the packet I'm going to create, I will be marking them that this packets, or sorry, this information, these bits are actually for the WhatsApp application, right? Similarly, there is a Chrome application. You are sending some request from the Chrome application toward the server, maybe on the internet. If that is the case, you are again generating this data. You are again generating that stream of water. But now here, these are the bits. Transport layer is collecting them, but along with that, application layer is saying that this is for Chrome application, right? Or maybe this is for some application, right? And it should be delivered to that application, and it should go to ABC. Right now here I am writing XYZ. Maybe it's an address, maybe it's an IP address, right? So there are different buckets here, and that is why the transport layer, when send whatever the information it is getting, right? So that information is so many bits here, right? Which transport layer is going to get. Transport layer will be getting maybe the bits from the WhatsApp application in yellow, 10101010 whatever, 001. And there must be few bits which it is getting from Chrome application. in the gray color, 0010, whatever, right? You never know. If that is the case, this transport layer, whatever we're seeing here, right, cannot send all the bits at once because it might be the limitation of the your copper wire, how much bits can be sent at once over this copper wire. So what transport layer is doing? It is making chunk out of it, right? These chunks at the transport layer is known as segments. It means that whatever the data it is receiving from the application in the form of that continuous stream of data, the flow of water, it is actually dividing them in a particular unit which is known as the segment. So the transport layer, the data unit is segment, right? Similarly, whatever is coming from the uh, Chrome application, the application layer is divided them into the particular segments. These are the segment for Chrome application, right? And transport layer is coding them that this data, whatever the segment I have created here, this is actually for the WhatsApp application, and whatever I am creating in the gray color, there is actually for Chrome application. Maybe the some as the analogy is always not correct. So you will come to see later that there is a little bit gap in this analogy, but yes, that is fine to understand, right? So transport layer is creating these chunks, that the yellow chunks are going whatever, right? These are the data which I am receiving from the WhatsApp application, and the gray color thing right here, which you see here, this is actually your data from the Chrome application, and now it is sending because it has done its duty. What were the duties of transport layer? First, it is checking, right? It is checking whether the destination is there or not. So Sanya, it has that IP address to where to send these packets. But actually, even those packets through which it is checking whether the destination is there or not, that information is actually also flowing over the network layer. We will see that. But to answer your question, yes, transport layer knows that the data which is right there in the bucket, yellow bucket, is for WhatsApp application, and it wants to go to XYZ. It is as simple as that. XYZ is the address here, right? So transport layer, once it's done its duty, converting this stream of data into multiple chunks of segments, now it is seeking help of network layer, and that is why it is forwarding the packet towards network layer. So this is my mistake, and this is the limitation of this board also, that I cannot draw application transport and then network layer just below it. So I'm drawing it on side, but you understand that this layer is just after the transport layer from here to here, right? The packet is going from transport layer from here to here. It is as simple as that. So transport layer is saying send yellow packet to XYZ, send gray packet to ABC. This is the instruction towards network layer. Now, network layer is more focused in sending all these segments towards the destination because it understands that IP address, right? But IP address is not there. But transport layer is saying that I do not know how you are going to do. Send yellow packets to XYZ address and send gray packets to ABC. Interesting, right? And that is why the intelligence of network layers come into picture when it sends data, right? It is not sending the data that this is only for the WhatsApp. So this is actually data for the network layer. Whatever transport layer is sending, network layer is saying, okay, the yellow packet, okay, this is for the WhatsApp application, but I do not care where it is going for the WhatsApp or Chrome. My duty is to send this to only XYZ, and that is why it put an extra piece of information here that this information, whatever it has received, should go to XYZ because this is yellow, and transport layer is guiding me that this yellow packet should go to XYZ. It is as simple as that, right? Similarly, the gray packet, this guy is saying that it should go to ABC. And now, whatever the unit you are seeing here, the starting Whatever is written in the yellow or the gray and the bits, this is actually data for network layer. This is same like transport layer is receiving some information from the application layer. That is data for transport layer, and network layer is receiving something from the transport layer. That is actually data for network layer. And then it puts some more information on the top of it so that whoever or whatever it's sending this data to can understand. So now this is your envelope, right? Here is the message in the envelope. Here is the address on the envelope. And anybody, in case of our post office analogy, a postman can easily see. He doesn't need to see what is inside the envelope. He just see XYZ. Okay, this Y want to go to XYZ. I'm going to send it to XYZ. What is XYZ? XYZ might be the complete address we were discussing. 394 Sarjapura, right? Bangalore, Karnataka, India. It has a limit, it is a logical structure, and that is why this post office guy were able to send. But now here, when this packet goes out from this computer by these multiple layers, when it comes out, it will be like this, right? Some address is written on it, and inside there's a data or the letter, right? And this XYZ, whatever I have written here, is actually has some logical structure which we are going to read today. That is the overall point of discussion today. It is going to take 1 or 1.5 hours understanding this address. What is the logic behind it? Because we understand the logic behind our home address. Now I will give you the logic behind these IP address. Believe me, it is very, very interesting. But the whole sole point is now the network layer is sending these messages with something on top of it. And whatever they put on top of this data, it is known as the header. Who is putting this header information? Network layer. What this header layer information contains? IP addresses, right? So this data plus addresses or the header is known as the unit at the network layer, right? So whatever the data you are receiving from the application layer, whatever you are putting on top of it as a header, if you combine them, this will become the unit at network layer. And what we call this unit? We call this unit at packet as packets, right? So whatever you are seeing here, these are your packets. Whatever you are seeing here, these guys, these are your segments. So the unit of data at transport layer is segment. I am just introducing some terms. So if I say segment, just try to understand I'm talking about transport layer. If I say packets, I'm talking about network layer. It is as simple as that, right? But most of the time, consider any network engineer, they are going to say everything as packet, right? Whether it's at layer 2, layer 3, layer 4, doesn't matter. But that is fine because most of the time we are dealing with the packet so that we understand. We always, it is a part of our blood now that whatever is going out here and there, it is packets. But if you want to be pretty, if you are from those person which is very peculiar about using words, then if you're talking about network layer, just tell them back. I make this mistake, right? But while teaching you, I will be extra cautious. But still, if I make mistake, please pardon me. That is it, right? So transport layer segment, network layer, and now what is happening, guys? If I give you, uh, although we were talking about whatever is as I mentioned, these layers, whatever I'm saying, layer number 5, layer number 4, layer number 3, everything is implemented right there into this laptop. So whatever is going on, whatever we have discussed till now, it is right there inside this laptop, right? But what we are getting outside, I am again making it really simple for you. Why? Because I do not want to go into the data link layer. So just try to understand. If we have this laptop here, the laptop A, which we're talking about, where Anjali was writing on the WhatsApp application or the Chrome application, right? At the end, what we are going to see coming out from here, we are going to see a WhatsApp data, and on top of it, somebody has written XYZ. So these are the packets which are going to which are coming out from this. Although this is not an accurate statement, but we do not know about the data link layer till yet. That is why I'm talking that whatever is coming out from this now, based on our knowledge, these are the IP packets. But where these IP packets are going, right? And we all know that these IP packets are going over the wire, because at the end of the day, this is nothing but the ones and zeros. And if they are going, and if I connect, suppose if I connect to a device, I do not know about this device name, right? But this is just like your postman. If you send this IP packet to him, he will see only this, whatever is written on top of this envelope, which is XYZ, because this is the data. This is just like your letter. And he has this capability to understand this XYZ and send packet on the basis of that. And believe me, guys, in computer networking, we call such device as routers, because routers understand IP address. Router, it's just like a postman. It see the envelope. It see whatever is written on top of it. And on the basis of that, it will forward the packet. And there are multiple routers connected in this world, right? And then basically we have another computer, which is Mr. Rahul's computer. This is somewhere in India. This is somewhere in USA. Mr. Rahul is sitting here, and your packet is flowing from routers to routers, right? You must be thinking why, in case of postal service analogy, this guy was taking this guy was taking the post and delivering actually to the end, but we cannot do this, right? Because try to understand the postman, he is limited to the particular area, right? We are talking about the complete world. And that is why if you consider the letter journey, it will going out from your post box to the office, and then basically and whoever is taking from the post box to office, that was another person, right? And that is what I'm talking about. This packet is going from these devices to another devices until and unless it reach to the final destination, which is your USA. USA, inside USA, the computer of Mr. Rahul. It is as simple as that. And when this guy receives, and I am oversimplify everything for you, because these, whatever I have drawn, these cloud, these are your different networks. Inside those network, you have these postmen sitting, which takes the IP address, which takes the packet and send it towards different networks so that it can be closer to United States of America. Having said that, eventually what is this computer receiving? This computer is going to receive a packet which is having this data, and on top of it there is a header, which is the IP header, in which XYZ is written. When it reaches here, of course, this computer knows that XYZ is my address, and Anjali should also knows that she is sending this XYZ, this packet to XYZ. Otherwise, how at the first place she is going to send, right? The minimum requirement in the post office service was, if you are writing a letter, right, you should post it inside the envelope and write the address. If you do not know the address, how you are going to send it, right? So Anjali knows the computer address of Mr. Rahul, which is XYZ, and that is why she is writing this letter. On the top of this letter, the address, and this computer knows, okay, this is for me, and then it has the authority to open it, although anybody else can also open it, just like in the postal service, if you do not encrypt it. So now the data is there, right? And as you all know, this is the yellow packets. If I'm saying yellow packets, the meaning is that these yellow packets are for WhatsApp application, right? But it is, in actuality, this is not on the basis of color, but transport layer also write in its header that this is for WhatsApp application. And if this is for WhatsApp application, it should go to the WhatsApp application. It is as simple as that. So this computer WhatsApp application is going to receive this message, and he will receive the message, hi, how are you? It is as simple as that. This is the wholesale communication, how the wholesale communication happens over the TCP IP. But yes, I have included only application layer, I have included transport layer, I have included network layer, where address, here we are talking about which application and checking whether the destination is there or not. Here we are talking about the application 2, right? We are talking about the physical layer too, because at the end of the day, whatever you are sending, these are going over these bits and right over these wires, reaching these devices. I'm not sure what these devices are, but yes, I just informed these are the routers, but we haven't understand what the routers are. But yes, these packets are going to these routers. It is as simple as that. You must be thinking that why this guy is so afraid of data link layer, why it is not including, and believe me, there is a proper reason behind it. You will come to understand about it tomorrow. When we talk about the data link layer, it does, if I'm not including now, it doesn't mean that it is not important. This is very, very important, right? If you have heard about whatever we have done till now, right? Whatever we have done till now, this is your routing or routing. I have a habit of saying routing, right? If you want, you can tell this routing, right? Based on the IP address, I am routing the packet or routing the packet that where it should go. But data link layer is all about the switching, right? What is the switching? If you have ever heard about it, we are going to talk about it. And that is why this complete course is more it's going to focus on your routing and switching knowledge. It means that layer 3 and layer 2, or network layer or data link layer. It is as simple as that. So with that, I would like to say that now whatever I would like to inform you regarding TCP/IP and how it delivers the packet, I'm done with that. If you have any doubt, any question, please let me know. If you don't have any doubt, at least raise your hand to tell me that you got it. You got the way that how the packets are going to be. I can see some hand raised. And thank you so much. Thank you so much, everybody. And I could see there are so many hand raised. Thank you so much, guys. And thank you so much, Sanya, for asking this question so that uh, I thought about it that how I should make it clear for all of you. Having said that, and I could see that there are 32 minutes, but that is perfectly fine. If you are enjoying the session, let's continue. If you have any doubt, just post your question. Now you can lower your hands down, guys. Perfect. So now here is where we left yesterday's session, from where to start, because we know, right? We all know for the fact that Mr. whoever the inventors of TCP/IP, they have broken this problem into 5 pieces. The number one piece is application layer. We know about it. It deals with the application. It is something from which you interact, right? Then the message from here to here go to transport layer. And it says that this message is for WhatsApp. It checks also whether the destination is there or not if you are using TCP. Then it goes to network layer, which is going to put the address. Then it is going to put the data, going to the data link layer. It is again going to put one more address. There is again a logical reasoning behind it. And then it goes to the physical layer. We all know about it, right? This is layer number 5. This is layer number 4. This is layer number 3. Network layer or layer 3 is same. Transport layer or layer 4 is same. Data link layer or L2 or layer 2 is same. If I say L3, network layer. If I say L4, TCP, or the transport layer I'm talking about. If I say physical layer, or this is an L1 issue, you should understand this is the cabling issue, because physical layers deals with the cable, right? The blind spot right now, if I say, is the data link layer, but it is not going to be. Pretty soon it will be pretty easy for you, right? But for now, if I talk about network layer, we should start from here. And the reason is, actually, this is one of the most important layer for the network engineer. I don't say that this is true, right? But most of the people, when they start learning, network layer is one of the most important thing, because it interacts with the transport layer. It also interact with the data link layer. Then you must be thinking that, Mr. Vishnu, if that is the case, you could have started with the transport layer, because it is also interacting with network application layer and network layer. I agree with you, but believe me, I am, and some of the moderators here are in this industry for 14, 15 years. You should take advantage of our experience. Let's start from the network layer. It is going to be benefit. It is going to give you some some cool stuff so that you can understand transport as well as data link layer. Having said that, let's talk about from where to start. And we are starting from the network layer, which deals with writing that address on the packet, whatever it receives from the transport layer. And this address is going to be your IP address. It is as simple as that. Let's move to the new board. I could see that there are hand raised from Khushi and Praneeth. Khushi and Praneeth, do you have any doubt or question? Or this is basically you forgot to okay, that's perfectly fine. Thank you. So we are starting network layer or layer 3. I am excited about it. Okay. So I have divided this board into two portions, the left hand side and right hand side, right? Let's talk about first the right hand side. What I have drawn here is there are three colonies. Okay. And these colonies are having houses. Houses have some number also, right? Maybe this is colony 1 and this house is number 1 of colony 1. This is number 2 of colony 2 and this one is number 3. It is as simple as that, right? Similarly, if I say colony 2, it is also having house number 1, 2, 3. I'm not saying that these colonies are going to be having only 3 houses. Maybe there are 256 houses are there. You must be thinking that why this number? He could have said 300, right? There is a reason. I'll let you know. So maybe in colony 2 there are 3 or 4 houses or maybe 10 houses, right? Or 20 houses. And then we have the colony 3 also. Here also we have number 1, number 2, number 3. It is as simple as that, right? And these colonies are connected with these roads. And these roads are very, very important because somebody from house 2 in colony 1 wants to go to house 1 in colony 2. They can use these roads to reach here. It is as simple as that, right? Very, very simple. I say that I haven't experienced that when I explain most of the things in this plain terms, people understand it. Believe me, this is exactly same whatever I'm going to tell you in the networking also. So first thing first, in your mind, you should understand this is networking is take whatever you read, whatever you see in the real life world. Maybe we all are 20 years, 20 plus age, right? I am more than 35, right? So we have some experience. We have taken experience from this world. Believe me, your complete networking is going to be based on those experience. If you understand the real world, this is whatever we see, the examples taken from the real world, right? So if anybody in home 1 wants to go to colony 1 wants to go to colony 2, they can use the roads and straight away go, right? Because people lives here in these houses. Simple, right? Now, if I say, if I'm talking, suppose Anjali is talking to Rahul here, and she is saying that Mr. Rahul, can you go to house number 2? Rahul is saying, absolutely, I can go to house number 2, but house number 2 doesn't make any sense to me, right? Can you tell me first which colony of house 2 you are talking about? Because there are 3 house 2s here, right? One in colony 1, one in colony 2, one in colony 3. That means that Anjali has to specify that you are going into the house number 2 of colony maybe 3. Then it is a clear cut information, right? So who is defining the complete structure? And I'm talking about only 3 societies or 3 colonies. Believe me, guys, your complete means whatever the India, or if I talk about the earth, it is structured like this. We have little colonies, right, which make states, which make uh, which make a country, and then country makes the entire world. It is as simple as that, right? So we have a proper structure in this address. But if I talk about the computers, right? These computers are going to be like your houses. So I am coming on the left hand side diagram, right? So I have created these clouds here. Cloud number one, cloud number two, cloud number three here, cloud number four, and I'm calling them network. Just like I'm calling them colonies, right? And you are pretty comfortable with it. Yes, colony, I have heard about it. If society, I have heard about it. On the left hand side, I'm calling something which is grouping my laptop as network. So on the left hand side, this is my these are my networks. And inside these network, if I see that there are people with the laptop, and now I'm not interested in people, I'm interested in their laptop, right? Because the whole sole purpose of having this course is to connect these laptops across the world. Not only laptops, your mobile phones or anything which can talk over internet nowadays. With the invention of this, whatever the new inventions going on, like Internet of Things, you would see most of the things coming on the internet, and you can manage them remotely. Because if they are on the internet, you can reach them to anywhere. Consider an example that if you are in Delhi, right, and your home is in Bangalore, and suppose in the night, in the you had some specific requirement that you have forgot that your machine or anything, your press or the machine or anything was on, right? And you forgot about it. Then if that thing is on the internet, and if you talk to that, you can talk to that machine over the internet. You can switch it on, switch it off, and that is how the world is going. And I'm talking about the 4 5 years back, right? Now these things are in most advanced phase. You see the home automation, right? Everything is possible. The whole sole point of telling is that we are talking about how to connect your computers, your mobiles, your devices which you daily use in your home, right? So if I say that this cloud consists of those devices, maybe the laptops, we are talking about here laptops specifically, or the PCs, these cloud contain one or more those PCs, right? For example, network 3 has 3 different PC or mobile phones. So I do not want to tell them every time the PC, then mobile phone or anything else, right? So I'm calling them with different name, right? With single name. This is going to be your host. If I say host, the meaning is and host. The meaning is it could be PC, it could be mobile phone or anything. Some people also call them and host or endpoints. I am again introducing some terms, right? But you should understand, because I do not want to call them every time PC, mobile phone, or your iPad or whatever, right? I'm calling them with a single name. And that means network 3 contains 3 hosts, network 4 contains 2 hosts, network 2 contains only one host, and network 1 contains 2 different hosts or 2 different PCs. As simple as that, right? So if I want to identify them, right, then I should be having some structure like this, right? Colony 3, house 3. Then I'm talking about this house. It is as simple as that, right? Similarly, if I want to communicate, right, or if I want to say I want to reach somebody here, I need to define that address for it. I can straight away say that I'm talking about network 3. That is perfectly fine. And I'm talking about third host of network 3. If I say, Rahul, can you point out, can you make a circle around the host number 3 of network 3? Then anybody can see that we Of course, this is network 1, I'm not talking about it. This is network 2, I'm not talking about it. This is network 4, I'm not talking about it. I'm talking about network 3 and the host inside it. I can see that there are 3 hosts, and if somebody had addressed them just like my house is, then this is going to be the 1, this is number 2, this is number 3, and I can say this is my host. Somebody was talking about this host, network 3, host 3. If I say network 4 4 hosts, then I need to number these just like the houses. This is number 1, this is number 2, and that is why this is network 4, host 2. It is as simple as that. So now you can see the right hand side and left hand side are just looking similar, right? So I have introduced 2 words here, very, very important, right? Network. Network consists of the devices, whatever you have. Maybe it consists of your host, but later on we can see that the network also contains switches and routers. But what are those? We do not know about them much, and that is why I haven't included. But yes, now we know a little bit about routers, so I can say that this network also contains routers, right? And then these networks are connecting over over this links or the cables, right? Just like your colonies are connected with this road so that anybody can move between colonies, right? So if somebody in the network 1, maybe this guy, wants to talk to network 2, this guy, right? How they are going to talk? They have this cable over which they can send their messages using the TCP/IP model, right? And you know how to send the message. Interesting. And suppose what is going to happen if this link is not there? Suppose, can you still reach? It is as good as saying that if this road cannot exist, can colony 1 reach to colony 2? Of course, it can reach via other alternate path, although the path is increased this time, but we can reach. Similarly, if this link goes down, we can reach from here to here. It is as simple as that. But you should be efficient enough to know that from where I should be reaching it. I can reach via other path too, right? From here to here. And guys, whatever we are reading here, these are actually traffic flows. When you become the network designer, you need to explain your customer that I am thinking that this traffic flow is more efficient because it is taking much time. And this traffic flow, the green, is basically more cost. There is more cost involved. So we are using this one, right? This is going to be as simple. Means if you learn from the physical world example, it is going to be always easy to learning, right? But now you understand that it's okay, man. You are saying that network 3, host 3, we know about it. But now the question is, can computer understand this language, network 3? No, computer is going to understand 1010. So let's see that how in only 2 states, ones and 0, we can encode this complete logic of network and host. It is as simple as that, right? So the next board going to contain this logic, and let's move to the next board here. So now I am talking about, say, network number 4 and this host, right? And if I say, suppose if I say that, and maybe I'm Anjali again talking to Rahul, and he's saying, and she is saying that, Rahul, do you understand network 4 host 2 or host 15? Suppose now I am numbering them. Maybe this network contains many hosts, right? 16 hosts, suppose. So this is the first host here. There could be the second host. I do not want to show, otherwise the diagram will become more cluttered. And suppose this host is my 15th host, suppose, right? And similarly here we have 20 hosts and we have the numbering too. So this host specifically is my 15th number. We can have that. If the houses are more, then we can have the 15th number house. There is no big deal about it. So now Anjali is saying that, Rahul, can you reach to this host? And Mr. Rahul is saying, which host? And she is saying, don't you see this big number? Can you tell me which host is this? And now Mr. Rahul is so confused that what is that number? And she is saying, I know addressing. I know how computers talk. I know how computer address other computers. Then Rahul is saying, okay, explain me too, right? And she is saying that computer only understand 1 and 0, right? And Rahul knows about it. That's fine. So if I talk about a bulb, right? If I talk about a bulb here, which is glowing, if it is glowing, then basically I can say the power is there. And if it is not, then basically 0. It means that this bulb can take two different states. Either it is going to be on, either it is 1, somebody has switched it on, and either it is 0, right? So if I have, and by the way, guys, we call them as a bit, and the bit can take only two values, ones and zeros. If I have one bit, I have two states. If I have 2 bits, how many states are going to be? 4. How? Suppose I have these 2 bits position, right? And I know this is the bit, this is the bit. So this guy can take 0 position. This guy can be 0, right? And in the meantime, this guy also can be 0, correct? And if I talk about another state, this guy can be 1, but this guy can be 0. This guy can be again 0, but this guy should be 1. Not should be. I'm just talking about how many combinations you can form with 2 bits, right? If I talk about it could be 1, then it could be 1. And interestingly, with 2 bits, you can have these 4 possible combination. It is as simple as that. And similarly, if you are going to have 3 bits, you are going to have 8. And you all know about it. I know you all are engineers and you must have read about it. If not, that is perfectly fine because this is not something which is very, very difficult. It's pretty easy, right? But the problem is we do not see, and that is why the Rahul is not able to understand what Anjali was saying. Previously, she was saying network number 4, host number 15. If that is the case, anybody can understand that she is talking about this. But now she is talking in cryptic. She is saying this is the address. Try to understand. And as I mentioned, that if you are having only 1 bit, then basically you can have 2 states. So if you have 0 bits, so 2 to the power 0 actually, and the formula is very, very simple, right? If you have 3 bits, then the number of states are going to be 2 to the power 3. If you have 4, then number of states are going to be 2 to the power 4, which are going to be 16, right? And believe me, if you learn only this thing, 2 to the power 0, what is the result of this? 2 to the power 1, 2 to the power 2, 2 to the power 3, 2 to the power 4, 2 to the power 5, 2 to the power 6, and 2 to the power 7. Believe me, you can understand the complete IP addressing. Do not believe? Just see this. By the way, guys, 2 to the power 0 is not 0. You all know it is 1. This is 2. This is going to be 4, 8, 16, 32, 64, and 128. It is as simple as that, right? So suppose somebody is saying, can you encode, can you write, I only understand decimal number, right? And that is the problem of Rahul also. Rahul is so habitual about decimal number that he cannot understand this mathematics, that what is written here, right? So there is a way, basically, that whatever is written in binary, you can understand that what its value in decimal, right? Decimal number has 10 different ways to showcase a number, which is from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So these numbers you are representing in decimal, but in binary you need to represent only in 1, 0, right? So if you consider this as 0, this is going to be 1, this is going to be 2, this is going to be 3. This is my decimal number. If I say 3, it means 1 and 1, right? If I want to represent 7, it is going to be all threes, right? 3 bits with all position 1, because this is 2 to the power 0, this is 2 to the power 1, this is 2 to the power 2. It means that if you add them, 1 plus 2 plus uh, this is 4, 1 plus 2 plus 4, it is going to be 7. So if you want to represent 7, 7 is going to be 1, 1, 1. It can be represented with only 3 bits. Interesting, right? And believe me, just understand this mathematics. I'm not saying that you need to be pretty good with respect to identifying whatever is written here, but that is fine. But now let's try to understand what is this number. So if I see that this is a 32-bit number, 32 bits, interesting. And what Mr. Raul is doing, he is trying to decode this message, what is written here. Now he understands the mathematics behind the binary as well as decimal number system. And believe me, guys, whatever we are going to discuss now on, it is going to be in decimal, because this is the problem I see in the network engineers. When I say that can we divide this network into 5? And here is my problem. Everybody start thinking in ones, zeros, right? 1 and zeros. We are not programmed to think in 1 and 0, guys. Computers are. We aren't. If that is the case, we should be always thinking in the decimal. And if you can think in the decimal, right, how computers are going to be thinking in the decimal, then basically it is going to be pretty easy, whatever the conversation we are going to have in next few boards. So whatever we are going to learn, we will see from the decimal point of view. And the reason is because we are programmed to understand decimal number system, right? So here is how Mr. Rahul is decoding this everything. He's saying that I know that from this 8 bits, the number here is actually 192. Very, very interesting. So these 8 bits represent decimal number 192. You do not believe? Just do the mathematics, right? Because where we are finding 1, we are finding 1 at the 7th position, right? And we are finding 1 at the 8th position. So this is my first position, 2 to the power 0. This one, basically we say 0 to 7, but actually it is 1 to 8, right? Whatever you say, 0 to 7 is 8. If I say 0 to 7, how many numbers are there? There are 8 numbers, right? If I start the counting from 0, this is 0, this is 1, this is 2, this is 3, this is 4, this is 5, this is 6, and this is 7. And 7th and 6th position is 1. So if I see 2 to the power 7 is equal to 128, 2 to the power 6 is equal to 64. If you add them together, it is going to give you 192. It is as simple as that. So Mr. Rahul is saying the starting 8 bits representing 192. It is as simple as that. And if you do the mathematics, the next 8 bits are going to represent 168. Interesting. The next 8 bits are going to represent 10, and the next 8 bits are going to represent, let me calculate, 15. Okay. So here, if I showcase this with the green pen, it is going to be, this is actually 15. Everything from here is 10. Everything from here to here is 168. And everything from here to here is 192. This is fine. Mr. Rahul has decoded this information. And now he's pretty sure that you are talking about this. And Anjali is saying that perfect. This is good. And so that we understand that these are 4 different numbers. Anjali is saying just put dot between them. So whatever you are seeing here is This is your IP address. But now Rahul is saying that this is fine. You just converted the binary number into the decimal number and then put the decimal between them. But what is the logic behind it? Right? I don't see any logic here. And here is my problem. IP address alone, whatever we have written here, I'm writing it once again, 192.168.10.15. This number doesn't have any logic, doesn't have any meaning, unless you write something after it. And that something is known with a name which is called subnet mask. It is as simple as that. The logic right now, Rahul is pretty convinced that okay, I can convert this binary number into the decimal, but tell me the logic behind it. How can I find a particular host out of these four networks, right? That where exactly this host is. This dot 15 could be here, could be here, could be here. And that is where I am letting you know, if you write only an IP address like 1.1.1.1 or 6.6.6.6, actually, logically, it doesn't have any meaning unless you write a subnet mask along with it. As simple as that. But now everybody should be curious about what is this mask value and what is the logic, right? And I hope this board is pretty clear to you. If you do not have, and if you have any doubt on this board, please do ask your question, right? So right now we are changing some of the thing for the today's session. We are going to have only one break of maybe 20 minutes or 25 minutes after half an hour, after 1.5 hours. So 1 hour is gone. We still have 28 minutes to go, right? We will be covering 2 or more boards, but I think you are curious enough to know now that what this subnet mask is and how actually it is adding some logic. And Rahul is still confused, but Anjali knows this logic and she is pretty confident about that. I can find with this information, right? And she is informing that even I can't find this with this information. I need to write a subnet mask, right? Let's see the meaning of this mask and how it is actually adding some intelligence over this IP address, right? So let's see that. Now, again, our two characters, curious characters, Anjali is here, Rahul is here. Both are talking, both are trying to understand what is the meaning, what is the cryptic language, whatever it is. And now we know that 192.168.10.15 is perfectly fine, but what this slash 24 is right now, if you see that we are talking about these 32 bits. And if I'm saying slash 24, the meaning is I am counting till slash 24 bits. From here to here, if you count, these are 24 bits, right? And these are only 8 bits. And if we add them, of course, these are going to be 32. So as I given the example of colonies to you guys, right? And if I mention colony number 3 and host number or the house number, whatever the house we have here, right? Whatever the house we have here, house number 1, sorry for my drawing, house number 1, house number 2. So actually that address contains two parts, the colony, perfect, plus actually the name or the number, right? With these two things, you can definitely come to know that this is colony number 3, house number 2. It is as simple as that, right? So if you see along these lines, Anjali is also saying, Rahul, that I have divided this number into two parts, right? And how I am dividing? I'm telling the logic right here that this is slash 24. It means that the starting 24 bits are doing something different than last 8 bits. It is as simple as that. Maybe the starting 3 bit, if I talk about the starting 24 bits, and if I count starting 24 bits from here to here, these are going to be the 8-bit thing, right? This is again the 8-bit thing. This is again the 8-bit thing. So we have these three. These are making till slash 24. So actually, this is just like your colony, or I can say this is just like my network. It is as simple as that, right? And whatever is represented by the remaining 8 bits, this is actually your house, or this is actually your host. There we had colonies and house. Here we have network and host. It is as simple as that. This is the logic. This is the only logic behind the IP address. It didn't have any meaning if we do not write this little slash 24 after this IP address. It is as simple as that. It is saying that the starting 24 bits are actually representing network, and the last 8 bits are actually representing your host. Very, very interesting, right? So if I say 8 bits are representing my host, and if I take this example, and if I say there are 200 hosts or 200 houses in this, then I would have written 1, 2, 3. I would have given number like this 1, 2, and 3. But here, your IP address is specifying that your host can be represented with 8 bits. And how many hosts can be represented with 8 bits? Do you know about it? If I have only 1 bit, it can have only 2 combinations, 0 and 1. If I have 2 bits, it can have only 4 combination. You all know about it, and that is what I'm asking, that if I have 8 bits, how many hosts it can represent? It can represent 2 to the power 8, which is actually your 256. Sorry for this. 256. What is the meaning? The meaning is simple, that if I have a big network, what I will say that I can represent this number with starting 3 octets. And by the way, guys, if we have 8 bits, we call them the octet also, right? Octa means 8. Octet. Do not get confused with bits and bytes, but you all should know that 8 bit can also make 1 byte. This is the unit, right? But if I say that the IP address is of 4 octet, you should be pretty comfortable about this. This is going to be 192 is going to be my first octet. 168 is going to be my second octet. So just like I was identifying colony, I can identify this cloud also with what? The starting 3 octet, which is 192.168.10. And inside that, we know that there could be maximum only 256 hosts because I have only 8 bits to number these hosts inside this particular cloud. It is as simple as that. So this cloud can be big enough to have 256 laptops, your mobile phones or something, right? I cannot draw to 256, but try to understand. Try to understand the emotions here. These are 256 and I can number them. This is my dot one or one. This is the second one. This is the third one. This is the fourth one. Maybe just like this, we have my 256th one, right? Or 255 one, because if I start from zero, and that is why most of the guys get confused here. If I'm writing 256, It can be from 0 to 255. 0 to 255 countings are actually 256. Okay. So if I say, where is my host number 15 here? Then I should see that this is 192.168.10.15. It should be part of this network. Great. And I can see this, the colony name is 192.168.10. This is my network. And inside that network, that there is a 15th host, and I'm talking about that 15th host. It is as simple as that, right? Interesting. Again, I don't see any question. It means that you are all getting it. And if you're understanding it, this is great, right? So now, instead of writing here the networks, network 2, network 3, we are talking more technically now. Maybe this network is 192.168.10. This network is 192.168.20. Of course, this is different than this because these are not same. This is .20, this is .10. Although the starting 2 bits, so 2 octets are same, but if you see that the starting alphabets of colony 1, 2, or 1, 2, or 3 are same, right? But we can differentiate on the basis of this, and that's why we are differentiating. These two networks are not same. This is .20, and maybe we have 192.168.30 here. And here we can see that this is 192.168.100 here. So if Anjali is saying, can you reach to this network or this host, whatever I am representing with this IP address, now Rahul is pretty comfortable about it, that he is understanding that Anjali is talking about this network because 192.168.10, that is the representation with starting 3 bytes, sorry, starting 3 octets, and the last octet here is actually the host number. And right now I have 2 hosts maybe, but I have .1 here, right? .2 somebody here, .3, and maybe this is .15 or 15. If that is the case, then this host or this laptop Anjali was talking about, now Rahul understand this logic. Believe me guys, routers are also going to understand this logic like this. Very, very interesting and very, very easy too. I have another board on it so that we are going to be absolutely clear about it. But now you must be thinking that I haven't, in my life, I haven't seen a network which is actually having 3 octet. I always see the 4th octet. It means that this guy is lying. Vishnu is not correct. And you are right. Although this is the whole sole point of the discussion, that on the basis of the starting 3 octet, we are going to differentiate the networks, right? We are going to differentiate the network on the basis of 3 octet, but there is a slightly different approach of writing the number. They say whatever the first number you are giving, right? Whatever the first number. So basically, if this was the network, my complete network 192.168.10, and we have this first network, this host, right, which is starting from .0, they say that this is your network number, right? So they are saying whatever the first host or the first host IP address you can think, that is going to be your network number. So 10.0 is going to be my first host. They are saying, please, and this is just a convention because this doesn't look good, 3 octets, right? And you must be wondering that what these guys are saying, doesn't look good means what? It doesn't look good, right? It is not how computer don't say that sometime it is going to be 3 octet network number, sometime it is going to be 4 octet host number. No, they're pretty consistent. So you are actually saying, do not write in the 3 octet form. Whatever the first number you have for your host, do not give that number to your host. Start with .1 instead, And whatever the first host IP address you have, it should be your subnet number. So the subnet number is going to be 192.168.10.0, and along with that you write /24. Why? Because /24, it means that we are talking about 192.168.10. These starting three octets are representing my network. The logic is going to be same, but yes, the representation could be different. बोलते हैं नाम में क्या रखा है, right? And maybe some of you might not understand, but that is fine, right? Having said that, I have one more board on it, and which is going to summarize all these things for you. And then probably we can take a break. Okay. So again, you must be thinking from the last two board, this guy is explaining us only the logic. But I think I strongly believe now that you must have understood something with respect to this IP addressing, right? Now, I just didn't write here those red so many bits here, right? Because from now on, we are going to talk more in terms of this decimal number system, right? This is more convenient. Even for people, this is also not convenient. People are actually more comfortable with the name. Suppose if I call Punish that you are 192.168.10.18, no, right? This doesn't, and this is pretty hard to remember also. People are more towards the name. And that is why generally, if I want to talk to google.com, I don't say I want to talk to 8.8.8.8 or something like this. I say google.com. So I'm just giving you, throwing some ideas on you that there must be somebody who is actually converting this google.com into the IP address, and there is an entity, a server, a device which converts this name into, and there is a complete theory behind it. If you have heard about domain name system, that is the thing behind it. But let's leave that conversation for some other time. Right now, as I mentioned, now again our curious characters. We have Anjali here, we have Rahul here. Now Rahul, Anjali is saying, can you find 192.168.10.15/24 for me in this complete network topology diagram? Rahul is saying, absolutely, I can do that for you, right? Now he's saying that this is that he's pretty sure that he needs to match first the starting three octet. He needs to match first the colony first, right? So 192.168.5. No, starting three bits octets are not matching, not even matching here because this is .7, this is .9. What is matching here? This thing, right? And also, Mr. Rahul has concluded some more information from /24. He is saying that the 8 bits actually are for the host. 8 bits means 256 hosts should be inside it. And the first IP address, which is going to be .1, .0, should not be given to any host because this is the convention used by TCP/IP2, right? And by the way, guys, there are some commands through which we can use this number 2 as an IP address, right? But I do not want to go into that nitty-gritty. Maybe once you come to the real networks, because we have a lot of shortage of IP address, right? We do not want to waste anything. And here exactly we are wasting at least one IP address because now this is becoming the network number, right? This is representing just like the colony, right? This is representing this cloud, that this cloud is represented by 192.168.10.0 because I have taken one starting IP address from this cloud, and that is representing now this complete cloud, right? That is 192.168.10.0/24. Why 24? Because the starting three octets are representing the network. And then we have .1 here, .2 here. Maybe this host, which is you can see this is .15 or maybe .14, and this is .15. So Rahul can immediately say that, see Anjali, I have found this IP address. This IP address is exactly here, right here in this cloud. And inside this is the host number 15th inside this IP address. I'm not sure whether you have switched on that laptop or switched off, but I can show you that this guy must be somewhere here, right? And believe me, this is how, guys, routers, your computers, TCP/IP are going to calculate. Now you know everything in the decimal. Computer is going to calculate everything in bits, but the calculation results are going to be same. At the end of the day, it is just the calculation, mathematics, right? 2 plus 2 is always going to be 4. If you have 2 apples and you are adding 2 more apples on top of it, you are going to get 4, right? If it is calculated by computer in ones or zeros, or in quantum computing, or in your normal decimal number system, there are going to be 4 apples as a result, right? It is as simple as that, right? So through this, you can see I can find my host pretty easily here, right? And this is the entire logic behind it. But now the question arises. Let me see what is the next board we have, right? And after this board, we will go into the break, guys. I know that you all are waiting for that, but uh, let's complete this board also, right? Because this is going to be pretty small. What we are doing here is we are having this again address, and we all know that this is representing this complete cloud, right? And we have so many hosts inside it. Unfortunately, I know that the 8 bits represent 256 hosts. I absolutely cannot I cannot put 256 hosts here, right? Otherwise, it would have made this board pretty cluttered. But try to understand, maybe this is my dot .1 host, this is my dot .2 host, this is dot .15 here, which Rahul has identified. This is right here. Maybe this is dot 255th host. This is 254 host. This is 223 host. Maybe, right? And it is not the case that if you have a particular uh, colony that the houses are going to be there for sure, but you do not know whether somebody is here or not, right? It is as simple as that, right? So somebody is saying that I do not want this cloud of 256 hosts, right? Although one IP address is gone in this, but he's saying that I even do not want 250. What if I want only 120 hosts? That is, I want only these many IP addresses. And you can understand that if this guy wants only 120, then you are wasting the remaining addresses, right? Because this guy is so comfortable about in the fact that I am not going to use more than 120 IP addresses. And here you have this complete range of /24, right? And guy, by the way, this is dot zero. I'm talking about this complete subnet, right? But as you know that I can give you only 2 to the power 0, only one address, or 2 to the power 1, only two addresses, 2 to the power 2, only four addresses, 8 addresses, 16 addresses, 32 addresses, 64 addresses, 128 addresses, right? So basically where 120 lies between 64 and 128, it means that basically I want to divide it, right? I can, if I have the 256 complete number, right? I'm talking about binary. Binary has some limitations, right? In decimal, there was no limitation. We can divide it into 10, right? Then 200, and then 46. No doubt about it. Different, right? But here, if I talk about binary, if you have 256, you can divide them into two parts. One is going to have only 128, other is going to have only 128, right? And this is what the requirement of somebody. He's saying that I do not want to waste IP address. I do not want this large network. So what you are saying, what you are suggesting, no problem. We can divide it. We can divide it into two different subnetworks, right? So here basically you can have address from dot 1 to dot 127, and below you can have address from 128 to 256. we can divide the network because this is the requirement, right? If you want to save IP addresses, you need to divide this network, and that is what we are going to understand. That is what we are going to learn. The concept here is we are subdividing the network, and if we are subdividing the network, believe me, we are doing subnetting. So subnetting is the next topic which we are going to discuss, guys. When we were into this board, we were talking about how to subnet, right? And before that, just wait a minute. Again, resuming. So we were talking about that if there is no requirement of 256 hosts, then we are wasting some IP addresses, right? And that is why we are going to subnet them. Whatever we need, we are going to use them. But in the meantime, I could see that there was a question also from Tarun, Tarun Patella, right? And the question was that uh, in WhatsApp, when we are sending a message to our friend, how we are getting to know their IP addresses, right? And that is what I was explaining you, that I am oversimplifying things. Actually, believe me, this is not how your WhatsApp works, but the basic principle is going to be same. So right now, suppose you have your mobile phone, right? And you send message to a particular contact, and that contact is also having this mobile phone with this number. Maybe this is mobile number A that belongs to you. This is mobile number B that belongs to you, right? So what you have done in your mobile phone, you have installed this application, and that is the magic of that application. What exactly it is doing, that there is no direct communication between this computer A or the mobile phone A to mobile phone B. Believe me, we are always talking about this direct communication, how the packet is going to be forwarded directly, but it is not the case with the most of the technologies. They do not do direct communication with the other end, right? Actually, what is happening is that WhatsApp has having so many servers on the internet, and when you install these application, WhatsApp, this application know where the server is, right? And whatever you write, actually it goes to that application, sorry, that server first. It is stored here. Just like you have an entity, it is saying that there are some messages from Mr. A towards this guy, this guy, this guy. And similarly, this mobile phone B, WhatsApp application is also connected to this server, right? And it continuously checks whether there is a message from me, and if there is a message, it is going to download it from here. So basically, there is a server involved here. There is no direct communication. But yes, I had to take an example, and that is what I'm taking, right? So do not worry. At the end of the day, how the server is going to get this, whatever the request, whatever I am sending, right? So the communication is not between mobile A and mobile B. The communication is between mobile A and the server. How it is happening? It is again using the TCP/IP for sure, whatever we have discussed. But yes, I have, as I mentioned, the analogies are not always 100% correct. So I think that you got the answer. If not, that is also perfectly fine. But here we are talking some client and server technology. Having said that, let's talk about, just wait a minute, guys. Let's talk about now how we are going to uh, divide this network, or how we are subnet. We are going to learn the subnetting, right? So as you all know that we were talking about this network 192.168.10.0, and 192.168.10.0 is actually uh, having 24 bits for the network number from here to here. These 24 bits are for the network number, and we have 8 bits for the host. Now suppose I want to divide this complete network of 8 hosts, or sorry, 8 bit host means 256 hosts are there, right? And if I write down the IP address which are present in this network, which is 192.168.10.0/24, the meaning is that we are going to have 256 hosts. I cannot write down all the 256, but you know that we are having the IP addresses here. The first IP address is going to be the network number, which is 192.168.10.0/24. The second IP address is going to be 192.168.10.1/24. Why /24 I'm writing? Because without this, nobody is going to understand where are my network and what are my host bits. It is as simple as that. If I talk about 192.168.10.2, this is going to be my second host. I cannot write everything, but as you can see, there are going to be remaining hosts 192.168.10.254 and 192.168.10.255. These are going to be your 256 IP addresses inside this network. It is as simple as that, right? And now there is no requirement of 256 hosts, and that is why you have decided to break this network into two different networks, right? And maybe you can save the you can use only first network for your whatever host you have, and then basically you can save the remaining network for the future use. It is as simple as that, right? So this picture should be clear that what we are going to do is we are dividing this network into two different parts, right? So you all know that if I divide this network into two different parts, how many hosts, and suppose this is my network number one, which comes after the division, how many hosts are there in this network number one? And you must be pretty sure that we are going to have 128 hosts here. Why? Because there were 256 hosts in this big network. And now what we want to do is we want to divide this network into two different networks. And that is why I am saying that we are having two network number one and network number two. It is also going to have 128. As simple as that, right? If I ask you what IP addresses are going to be inside this first network, then you must be thinking that, of course, if I have divided, then starting 128 IP addresses should be part of network number one, and addresses, the remaining 128 addresses should be part of network number two. It is as simple as that. And if I write that, you must be pretty convinced that the first IP address of this network is going to be 192.168.10.0/24, right? For now, let's not write the /24 because we will be talking about it. Then the second IP address is going to be 192.168.10.1. Third IP address is going to be 192.168.10.2. You should start thinking in your mind that what should be the last IP address. The last IP address is going to be 192.168 because we have divided this network into two parts. The last IP address is going to be 10.127 because if you start from 0 and count till 127, the number of IP address you are going to get is 128. It is as simple as that, right? Now there is another network which is again going to have 128 hosts. What are those hosts going to be? Those hosts are going to be 10.168.10. What should be the first IP address? Remember, the starting IP addresses from 0 to 127 were taken by network number one right here. So we are going to start from 128 from here. Then the next IP address is going to be 10.168.10. Sorry, not 10. Extremely sorry for this. This is 192. This is again 192.168.10.129. Then 130. If you go like this, the last IP address is going to be 192.168.10.100, sorry, 255. And if you count from 128 to 255, you are going to get 128 hosts. This is what was the requirement, right? You can use this network, the starting one, for now, and you can use it later when you have more hosts in your network, or when you want to create totally different network. It is as simple as that. This is actually the subnetting, guys. But yes, again, let's try to understand more. Similarly, if somebody says that I do not want 128, I want 64 hosts in, then basically you need to divide this number of hosts right now, because you are dividing number of hosts at the end. This network is representing how many hosts are there, right? As simple as that. If somebody is saying that I want 128, then you are exactly dividing this complete network into two different parts, right? It is as simple as that. Somebody is asking that it is necessary to divide the IP address into two equal parts. No. Or four equal parts. No. But this is some of the limitations, right? As I mentioned, that in binary system, you can have 2, 4, 6, 8, 10. Sorry, not 10. 2, 4, 8, 16, 32. So if somebody is asking for the 30 hosts, then you are going to give the minimum, because 30 doesn't fit in 16, right? Not in 8. So basically you are going to give them the 32. It means that you are going to need a few things for that, right? I will be answering this question. And thank you so much, Aman, for asking. But you are asking it as a wrong place. You should not ask it into the chat section. You should post your question into the Q&A. Okay? Having said that, what we are doing here, we have divided our complete network into two parts, right? Two equal parts. And now we are talking, right? But do you think that what should I write as this subnet mask here? If I write 24, then it is going to give me, and you all know that the first IP address is going to be the network number. So the network number is going to be 192.168.10.0 for sure, no doubt about it. For this network, the network number is going to be the first IP address, which is going to be 192.168.10.128, no doubt about it. But what should I write after this? The subnet mask should be 24. If I write 24, then there is a problem, because if I write 24, then it means that the starting 24 bits are representing the network and remaining 8 bits are representing the host. And if 8 bits representing the host, then we have 2 to the power 8 is equal to 256 hosts, which is not the case here. Here we are having only 128 hosts, right? It means that this slash number, whatever we write after the slash, which is a subnet mask, should be changing. Suppose if I write 25, will it fit? Absolutely it is. Why? Because now I am saying out of 32 bits, 25 is representing my network and only 7 bits are representing my host. It means that 2 to the power 7 is equal to 2 to the power 7 is equal to 128, and that is what I have, right? Interesting, guys. So now I should be writing slash 25 here, right? Why slash 25? Because now this makes sense to me that if I write 24, there are going to be 256. So if I write 25, there are going to be 2 to the power 7, because 30 out of 35, 32, 25 is the network number, and we have 7 bits for host. Similarly here also, right? If I write 192.168.10.128/25, I should be writing 25 here. But as you can see that we have now two totally different network. If I showcase you here, we started from, and guys, this is very, very important topic. Believe me, I can see a lot of network engineer, lot of engineer who do not know this concept. But this is very easy. If you understand, if you are getting it, it is going to be great when you literally face the customer. You are going to be rock solid because we are building our fundamentals knowledge strong here. So from where we started from a big network, right? Big network, which is having IP address of 192.168.10.0/24. Somebody says, I do not need all the 256 IP addresses, and that is why I'm dividing them into two different networks now. This one contains 128 hosts, and this one also contain 128 hosts. What those hosts are, you all know about it. Here, basically, those hosts are going to be starting from 192.168.10.0 to 127, and here these are going to be starting from 192.168.10.128 to 255. We all know about it, but now consider, just visualize, just try to visualize. Actually, these two network are from this network. So this is basically the top network, which you have divided into two parts, right? This one and this one, right? So if I say here, what should be the subnet mask which you are going to write here, or what should be the number of this network? So you all know that the first number is the network number, and we can straight away say the network number here is going to be 192.168.10.0, and here the network number is going to be the first IP address 192.168.10. Not 0. It is going to be the first IP address of this network, which is going to be .128. It is as simple as that, right? And now there is a difference of number of hosts. Previously, because of this 24, we have 8 bits for host, but now we do not want 8 bits for host. It is as simple as that, right? So we are taking some bits from the host. How many we are going to take? It is going to be very, very simple because you need to make 120 hosts into a particular network. As I mentioned that you should know this calculation. 2 to the power 0, with 2 to the power 0, you can make only one combination. 2 to the power 1, you can make two combination, and similarly 2 to the power 7, you can make 128 combination. It means that you can number 128 hosts with these 7 bits. It is as simple as that, right? So that is why I have to write here, instead of 24, I have to write 25, because now it is making sure that the starting 25 bits are representing the network, and ending 7 bits are representing my host. Similarly here, /25. It is as simple as that. And guys, believe me, this has been asked many times. There is many problems with respect to this question, that if I ask, suppose I have an IP address of this host, suppose the IP address of this host is 192.168.10.100/25, and I have another host right here which is having IP address 192.168.10.200/25, and if I ask you, can you tell me whether this host A and host B are part of the same network, or they are in totally different network? Now you know the concept, right? You will say that dot 100 is part of this network, the green network, right? Somewhere it should be here because this address range is from 10.0 to 10.127, right? And this network is actually from 128 to 255, and that is why 200 is part of the network number. This, if I say network, this is network number 2, this is network number 1, then purely host A is part of network number 1, host B is part of network 2, number 2. I am spending too much time here, guys, and the reason is this is going to be with, this should be with you forever if you want to be in the networking field, right? You should straight away see two IP addresses and can tell whether these part of that same network or not. If you can't, it is a problem because whatever we are going to learn tomorrow's onwards, mostly things are going to be here. Routers are going to work on this principle. Your switching is going to work on this principle because if I say a statement that switching is only relevant, right, inside a network, then you should understand that I'm talking about a particular network and I'm talking about the communication between the host of this network. If we want to communicate between networks, then we need something else. You are not going to understand these statements if you don't understand it, right? Some of you must be thinking that nowadays we have subnet calculator. We do not need this mathematics. I totally agree with you, right? But to understand internet protocol, to understand layer 3, to understand how routers work, if you have this knowledge, then you can easily get that concept, otherwise not. And this is very, very simple, guys. This is not that difficult. You don't use the calculator to add 20 plus 30, right? You know for that. Right? You can argue with me, why can't we just add 10 plus 20 using calculator also? You can, right? But I would say that you should have some basic understanding of these numbers and how basically we add them, because this knowledge is going to be required. So whole sole thing is that this host A and host B are totally different in totally different networks, right? It is as simple as that. But most of the time I get an answer that these two are part of the same network. And when I ask how, people say because we have same subnet mask. Believe me, guys, this subnet mask is to calculate to which host this network part. You should immediately understand. As soon as I write /25, you should immediately understand the network, the range of this network is from dot 0 to dot 2, 127, because there are only 7 bits for host and only 256 hosts can come here. It is as simple as that. If somebody is writing 192.168.10.236/25, of course, right? You should understand. First thing first, you need to calculate what is the range of this network. The range of this network is going to be, if I may say, then you need to think that okay, this is /25. And by the way, guys, whatever we have learning, I am not doing mathematics in 1010. I know that is also easy. You can get it. But if I do not want to use pen and paper, I want to do all the calculation in my mind. I am habitual of doing in decimal, and that is what I am teaching you here, right? Decimal is good because we understand it. It's more human, right? So if you see /25, the meaning is 25 bits are for your network, 7 bits are for your host. And if there are 7 bits, then basically we all know for the fact that 7 bits means 128 addresses. And if I see that the starting 25 bits are for my network, then 192.168.10. These are definitely going to be same, right? Because these are making my 24 bits, right? And then dot, this is 236. So if I divide the last segment, which was previously 256, right? I want to divide it. So the first network is going to be from 10.0 to 10.127. And of course, 236 is not part of that. Then means I am not part of this network. I am part of this network, which is from 10 to 127, sorry, 28 to 255. It is as simple as that. And that is how you calculate the range. If you do not get it, I would say you should watch this recording, right? Again, it is as simple as that. But believe me, after this class, after today's session, if I give you two IP addresses and if I say whether these IP addresses belong to same network or not, you should be able to calculate it, right? Because this is important. These are going to be asked in your CCNA network exam too, right? But there are something which I still did not let you know. And the first thing is that the first and the last IP addresses are actually very special addresses. The first address is whatever you have is known as your subnet number. We all know about it. This one and this one is your subnet number. And the last IP address is actually known as your broadcast address. What is the meaning of this broadcast address? Do not worry, I will let you know. But for now, it's just a simple term, broadcast address, right? The first number, subnet number, the last number is broadcast. It means that out of these 256, if I talk about, then you are not able to use the dot 0 and dot 255 if I'm talking about slash 25 for network, right? Why? Because dot 0 is for the subnet number, it is reserved, and dot 255 is for your broadcast number or broadcast address. What is that? I will let you know. If I talk about this network, right? This one here, if I talk about this network, then the first number here is dot 0 for sure, and the last number here is for 200 and 128, 127. It means that I cannot use 127.0 while numbering my host inside this network. I can use from dot 1 to dot 126 only. I can use 126 numbers because dot 0 and dot 127 is reserved. So if you want to calculate the number of hosts, and then of course, whatever the number of bits you have, for example, for this network, you have 2 to the power 8 hosts because you have 8 bits, 256, and you cannot use the first IP address and the last IP address. It is going to give you 254 IP addresses, right? So 2 to the power 8 means 254 IP address, usable IP address, because 2s are reserved. So do not get confused. If I say 254 or 256, you should understand that the first IP address and the last IP address are reserved by this protocol itself. But what is this broadcast number? What is that broadcast address, right? I will let you know the broadcast address straight after this requirement. Previously, somebody was thinking that I have to divide this network into two parts only, and then basically the subnet mask get changed from 24 to 25. We all know about it, right? And in other words, we can say that 7 bits of previously we were using 8 bits for host. Now we are using 7 bits for host. It is as simple as that, right? Now that same guy is telling that I do not want to use, I want to divide this network into 4 parts. Then you must say that I just divided this network into 2 parts. Let's divide it one more time. So we are talking about this network now. Which network? This 192.168.10.0/25 here, and here also 192.168.10.0/25 here. It is as simple as that, right? Not 0, it is going to be 128. Sorry for this. Let me write it again. 10.128/25. Let's divide it. If you divide it now, you know that this network contains 128 hosts. This network contained 128 hosts, and the overall network was 256. If you want to divide it into four parts, equal parts, then it is going to be 64 in each, right? Previously, you were dividing it in twice, and that is why 128, right? And we are using the decimal. I am again and again repeating. We are doing the calculation in decimal. This is very, very important, right? Although you can find so many videos inside Cisco, also Cisco, outside Cisco also, right? Who can teach you in 1010? I am not interested in that. That is also very, very simple. If you want to go that way, please do, but understand this. The whole sole point is just understand this logic. Now we are dividing this complete network into four parts, and you all know for the fact that if I divide it, then the first network is going to be having 64 hosts. There are going to be four more networks, right? And if I say this is going to be my network number one, then the network number one is going to having 64 hosts. Then we are going to have network number two. This is also going to have 64 hosts. Network number three is also going to have 64 hosts. Network number four is also going to have 64 hosts. It is as simple as that. From where to where? You can easily calculate first network, and of course you are breaking this. So dot 0 to dot 127, you are dividing it into half, right? 0 to 63 should be go in one network, and 64 to 127 goes to another network. And that is why I'm writing the range here. Here, the first IP address is going to be 192.168.10.0. The second IP address is going to be 192.168.10.1. 192.168.10.2. You must be thinking that why this guy is repeating too much. Repetition is actually good, because if we repeat things, it goes into our subconscious mind. You won't believe that whenever, means even after 30, 45 days, if you are revising this, these things are going to be natural on you. Why? Because you have understood it once, right? So 10.2, and the last IP address which is going to be here, if the part of this 64 is going to be 192.168.10.63, because from 0 to 63 you are going to have 64 hosts. Similarly, in the network 2, the first IP address is going to be 192.168.10.64, then .65, and if you go ahead, it is going to be, the last address is going to be 192.168.10.127. If that is the case, if you count from 64 to 127, it is going to give you the result 64 hosts, right? But do you think, what should I write after this number? It should be 25. No, if I write 25, then 7 bits are for the host. 7 bits means 2 to the power 7 is equal to 128. We now do not have 128 bits. We have now 64 bits, right? Sorry, 64 hosts. It means that for 64 bits, 64 hosts, we need 6 bits. 6 bit for the host portion. Then overall IP address is 32 bits, then we are going to have 26 for network portion and 6 bit for the host portion. And what you write after this, you write network portion, which is going to be yours 26. Now there is a new mask 26. It is as simple as that. Here also 26, right? But we have talked about only 2 networks. Let's talk about network number 3, which is again of the 64 host. And now we are dividing this guy, right? The starting 164 host should go into the network number 3, which is going to be your 192.168.10.128.129, and the last address should be .191. As simple as that. because 128 to 191 are going to be your 64 IP addresses. What should be the mask? The mask is again going to be 26. It is as simple as that. What should be part of the network number 4? You all know for the fact that the first address is going to be 192.168.10.192.193. Similarly, 255 slash 24, sorry, slash 26, 26, 26. It is as simple as that, because 192 to 255, it is going to give you 64 results. You all know for the fact that what is the network number of network 1? Can anybody guess? Of course, the first IP address is going to be the network number. Then the network number of this guy is going to be 192.168.10.0 slash 26. You should immediately calculate if this is a 26 and 6 bits are for the host, then we are talking about, because we are talking from the dot 0 perspective. So dot 0 to 63 we are talking. Similarly here, the first number is going to be your network number. Network number is going to be 192.168.10.64 slash 26. Here it was 10.0. Here for this network, let me write with the green pen, it is going to be 192.168.10.128 slash 26. For the last, it is going to be 192. It's interesting, I'm not able to select the pen. Yeah, 192.168.10.192 slash 26. It is as simple as that, right? Please do ask question if it is not making sense, but I say it is making sense, right? But as I informed you that we haven't talked about the second number, which is the broadcast number, right? So let's understand the broadcast piece also, and do not worry about it. It is again going to be simple. We will take the analogy and we will decide. But now what we have done, if we talk about, we started from the big network, which is 192.168.10.0. I am getting my echo back. I think now it's fixed. Sorry for this. 10.0 slash 24, which was having 256 hosts. And now what I did is I have divided this into multiple pieces, right? The 4 pieces. And you all know for the fact that this guy was 192.168.10.0 slash 26. This is 10.64 slash 26. You can write the starting one, 192.168.10.192 slash 26 and 192.168.10. Sorry, I made a mistake. This is going to be 128 and this is going to be 192. It is as simple as that, 26. And now from this big network, we have derived these 4 networks. So if I write 2 IP addresses again, if I write 192.168.10.100 and 192.168.10.200, and I ask to which network these guys belong, then you simply say, Mr. Vishnu, your question is absolutely wrong, because individual IP address doesn't have any meaning unless you write the subnet mask. And then I would say, I agree to you, and I'm writing 26 here. Now tell me whether these are part of the same network or not. Then you check the range. You do some mathematics in your mind, and you are going to find that from 64 to 127 lies in this network. This is part of network number 2, and this is part of network number 4. These are not part of the same network, guys, right? As simple as that, right? But now the first IP address is for the sub network number and the last IP address is for the broadcast. Let's try to understand what is the meaning of broadcast. The meaning of broadcast is same, whatever you understood. right? From your normal life. So if we have a FM radio station, right, and it is sending a song over a particular frequency called 93.5 FM. Anybody who is listening on this frequency 93.5 FM, or basically if you have radio or your mobile phone, you can tune into this frequency, right? And you can get this message, right? Basically, it is broadcasting to everybody. Whoever is interested, just tune into this frequency. It is as simple as that, right? This is what we know from the broadcast, right? Now, suppose if I have a particular network, the same network which I'm talking about, the same network of 256 hosts, guys. 256 hosts. What was that network? The network number was 192.168.10.0/24. And suppose if I want to send a message to everybody, then everybody is having the different IP address. This might be having 1, this might be having 23, this might be having 26, maybe 200, then dot 100, right? Because it contains 256 hosts. And now I want to send the message to each and everybody at once. Then what should be its IP address, right? Because at the end of the day, whatever we see the message, the data, I should be writing at the top of it the IP address so that it can reach there, right? So the last IP address is reserved for this. If you want to send a message to everybody, you should write here 192.168.10.255. And if you write this, then basically this is the uh, rule, or you can say this is basically inbuilt in the protocol, that the last IP address is for the broadcast address. Every router is listening on this router address also, right, which is 255. Every device can understand that if I am part of this, means if my IP address is .200 /24, I can calculate what is my subnet mask, sorry, so what is my broadcast address, and it start listening on that too, right? So .255 is reserved for the broadcast address, and that is why I'm saying that if you have 256 hosts, 2 addresses are gone, one in mentioning this number, subnet number, and last in mentioning in this two. But this is efficient, right? If you want to send a packet to everybody, then basically it is going to be your 255. Then basically it is going to be like this. You will be using .255. It is as simple as that, right? So now if you want to calculate the broadcast number and subnet number of all these, you should be very comfortable with this. Last IP address of this network is going to be 191 dot, right? Total IP address 192.168.10.191. This IP address is the broadcast address for network number 3. Similarly, here also 127 is the broadcast address for this network. Similarly, here also .63 is the broadcast network for this address. It is as simple as that. This is what is known as networking, right? Most of the guys says that you have taken one of the most simplistic example of subnetting. Yes, I have taken, because we are actually dividing this /24 into, first thing first, we have divided into /25 to see that there are 128 hosts, there were 2 networks. Then we divided into 26 to see that there were now 4 networks, and every network contains 64 hosts, right? And if you see a pattern here, if I show you again the pattern, right? So we started with 192.168.10.0/24, right? It was only one network which was having 256 hosts. So network was 1, host were 256, right? So if I made a table like this, then it is going to be uh, quite intuitive for you. For network number 1, uh, I can write there were only one network, not table, which is containing 256 hosts, right? When we divided this network 192, 168, when I write 10.0/25, I could see that there were two network, right? There were two network, and every one means both of them were having 128 hosts. Guys, I am again writing this because this is again very, very important. Third thing is 192.168.10.0/26. If I say 26, then you were getting 4 networks and 64 hosts in per network. Can you see the pattern here? Here we were saying whatever the numbers we have, we were using all of them, means this was my one and single network, right? But I am reducing the host bit here from 24 to 25. That is why I am having 128. Now I have given one bit. So basically what I'm doing, previously 8 bits were there, right? And all 8 bits were part of this host. Now I have taken only 7 to make the host and 1 bit for the network. If I'm using 1 bit for the network, 1 bit can take only 2 places, and that is why there were 2 networks. If I'm talking about 26, 26 means basically now I have only 6 bits. Where were those 2 bits gone? Those 2 bits gone for the network portion, right? 2 bits, that's why we are going to have 4 network. Similarly, in case if you are seeing 27, then we have 5 bits for host, means 32 host, and then basically we are going to have only, then we have shifted from here to 3 bits towards the network. It means it is going to have 8 networks of 32 hosts, and if you add them, those are going to be 256. It is as simple as that, right? If you are getting it, this is really, really awesome. If not, it's a problem, right? You should see this once again, right? I am open for your questions now. And believe me, if you want to divide this further, please do divide this, right? But, and here is the exercise for you. Now, I have changed this. I have absolutely changed this, right? Into /16. Previously it was 24, and now you need to divide this /16 into 2 network. What is the meaning of /16, guys? The meaning of /16 is that we are having 16 bits for network, and we are going to have 16 bits for my host. And try to think what a huge network this is. 2 to the power 16 means 65,536. These many hosts. Insane, right? If it is a huge company of having 50,000 employees, then basically he can have this range, right? This is great. But now what I want is I do not want this huge network. I want to divide into 2 parts. Then you must be thinking, yeah, the calculation is slightly bigger, but should be simple. If I want to divide this into 2 parts, then the one part should be containing 163, sorry, 32,768, and here also 32,768, right? It is as simple as that. But now, can anybody tell me that how 192.168.0.0/16 network having these 65,000 hosts or 65,536, right? If I talk about only, we are not talking about subnetting at the first place. If you get that, then basically you come to know I'm just talking about how, if I am saying that this network contains 65,000, right? 536 hosts. What are those IP addresses? Can you write it for me? Then you must be saying, first draw a cloud. Okay, let me draw a cloud. And you are saying inside this, there are so many hosts. Perfectly fine. And now start giving them IP address. Then I will be saying, yes, you are right. So you are saying first write this, the IP address of this guy is 192.168.0.1. I'm saying, okay, perfect. Because dot zero we have already taken for this. And this guy is going to be, the other guy is going to be 0.2, then 0.3, right? 192.168.0. Then I will be thinking that this way you will be reaching only 255 hosts, right? Because the last address is going to be 0.25, 192.168.0.25. Where are the remaining address? I want to see 65,000. And then you are going to say, Mr. Vishnu, here, basically starting two octets are for the network, but here the remaining two are for the host. And now we can change this octet to, this is very, very important, guys, because most of the guys complain me that you explain /24, which is very, very simple. Why don't you explain 16, which is very, very difficult, right? It is not difficult at all. First, tell me what are those 65,536 hosts? These are just 25, right? 255, sorry. So the next are going to be, you all know, 192.168. You are considering this only 0, right? This could be 1. And then you are repeating 192.168, 1.1, then 1.2, then 1.3, then 1.4, and similarly, last 1.255. Interestingly, then you can say that okay, that 255 hosts were here. I have marked them 255 here. Then what? Then I can start 192 on 168. This one is over. Then I can say this is 2. And then I'm going to start 2.1, 2.2, 2.3, and similarly 2.5. And similarly, I can change this position and this position also because these two are my host. And that is, if you calculate 256, right? Every time. How many times you are going to calculate? This 256 time. It means that 256 into 256, it is going to give you the result 2 to the power 8 into 2 to the power 8. If base are same, powers can be added 2 to the power 16, and this is the same number, right? Which is 65, 5036. So that is how there are so many hosts in this network. This one network is suffice for a company which is having maybe 55,000 or 60,000 employees. It is as simple as that. But there are some big problems associated with big networks. What are those problems? We are going to definitely learn into the tomorrow's session. And that is why we are dividing the network. And that is why I'm saying that I am not interested in this huge network. Although my employees are 55,000, but I cannot put all the employees in one network. I want to put them in different network. I mean, somebody is working in human resource, somebody is working in HR, somebody is working in marketing. I do not want to put them in one network. There should be different network for my organization, right? Interesting. And that is what I am saying. Can you do this exercise in your free time? Believe me, it is important because the end goal is why we are here. There are two things. We want to complete this CCNA certification. That is okay. That may be required. But the most important thing for me at the end of the day, you guys are going to face the customers. And if you are rock solid, right? If you know things to their core, these are the fundamentals of networking, whatever we are reading, right? And if you have those fundamentals strong, believe me, there is not going to be any problem in troubleshooting the network and design the network. People are having problems here. They do not have fundamentals good. And if they want to troubleshoot it, it is going to take, maybe they can, but it's going to take a lot of time and energy. Spend your energy right now. You can see the difference when you are there, right? I'm not sure whether the Prashant has informed you about this training or not. Believe me, this is the first time we are having this training like this way, right? So the exercise for you is, and maybe you can post your answers, right, over the group, whatever we have here, that I want to divide, first thing first, this network into two parts. Then basically there is going to be network number one, there is going to be network number two. I would like to see what is the network number of this first number and what is the broadcast address. It means that I am interested in knowing the complete range here. And here also I want to know, right? And you need to continue doing this exercise. Now I want four networks out of this network, right? Network number one, network number two, network number three, network number four. I literally want to understand what is the broadcast address and subnet number of network number one, what is the broadcast address of net and subnet number of network number two, three, and four. If you can give me, not now, just have everything in this in your free time, and then you should be good to go. It is as simple as that. So this is what, and there are going to be questions on this. So I have made that base strong, right? If you know all these things, then whatever the question you are going to get, maybe you can answer them, right? Interesting. Anybody, any question, any doubt? Do you fear with slash 16 now? Because I know you guys are pretty smart, everybody, right? Okay, give me a hand raise if you don't have a fear with slash 16. Okay, I am getting a lot of hand raise. Perfect, perfect. This is good, absolutely fantastic. But what for others, if the people are not raising hands, do I think, and there are so many people, like means we have around 70, 80 here, and if I see that there are many who have not raised hand, do you feel problem in this, right? See, there are only two outcomes. Either you get it or you don't get it. If you don't get it, please ask the questions, right? Okay. So there is a question from Kanak Sharma that when we'll get the access to the course on the bridge wire, you will get it, right? Prashant will be sending me the list of you. And for that, basically the first requirement is you just go and register with your Cisco ID, not with the Cisco password. I am again and again saying, right? And once you do that, probably today by tomorrow's 10 p.m., you will be getting the access, right? But as I mentioned, do not depend on the recorded version. Believe me, guys, if you are looking forward for that, there is a tons of material available on the YouTube, right? Why we are doing this live? Why we are not playing YouTube videos in front of you? Because you can ask questions. So do not be only dependent on the recording, right? Having said that, let's move to our next board, and you can down your hands, right? Okay. So last board of today's session, but actually you won't believe I have created many more. But unfortunately, we are not going to introduce the routers today because it is going to take more time, and I can see that the people are means 2.5 hours continuously studying, and we have done a pretty uh, heavy topic today. And believe me, if you get that, then The remaining networking is going to be pretty easy if you got that. And some of you might be thinking that is that what I get everything? And believe me, the entire networking is like this. Doesn't matter if you are reading a routing protocol. You must have heard about BGP, Border Gateway Protocol, or you're talking about OSPF or anything else or software-defined networking, right? Everything is just like this only, this much simple. But you should understand why we are doing this. Whatever we have learning, there is a specific why behind it. If that is not clear to you, that is a problem. Okay. I could see that there is a hand raise from Tarun, Priyanshi, Khushi. Okay, perfect. So now the question is, we understood IP addressing. We know that a particular device or particular host in the network is going to get an IP address. There is no doubt about it, right? And we now understand the logic also, that what is the logic behind this IP addressing. We all know about it now. And if that is the case, then can I find that postman who can take this envelope, which is having this IP address written over it, and forward it to somebody else? And now we are taking the again example of Rahul and Anjali. Here we have Anjali, and here we have Mr. Rahul, right? Rahul is in Delhi, Anjali is in Bangalore. Okay, I made a mistake. I think this is correct. That's 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 okay. So Anjali and Rahul, one is in Bangalore, another one's in Delhi, and now through the application layer, through the transport layer, we all know that something is coming out, which is the IP packet, right? IP packet is going to contain the data portion, which is right here. This is 10 or hi, hello, whatever is written here. And then on top of it, suppose I am writing here, by any chance, this Anjali knows what is the IP address of Mr. Rahul's computer, and suppose that IP address is going to be 192.168.7. Of course, it should be from the 7 range, and suppose the IP address is 7.100/24. Anjali knows about it, and that is why, while mentioning, she is saying that this packet should go to 192.168.7.100, and that is why I am going to write it here, right? This is going to be 192.168. Okay, now let me remove this. I need to draw the complete packet. Okay, so that I can include the IP address into it. So here is my IP header, which says specifically that the IP address is going to be 192.168.7.100. So this is the address where this packet wants to go. This is the complete packet which is coming out from this laptop, and I'm not sure how, but this packet is reaching to this intermediate device. I do not know about this. For me, this is just a postman. Do not worry, we will be introducing them tomorrow, right? But what Anjali is doing, Anjali wants to send this packet to Rahul. She knows the IP address. She's forwarding his computer's TCP layer the application layer generated the data. Then application layer say, transport layer say they should go to the WhatsApp, and then basically we have the IP address, right? And this packet is forwarded to R1. On what basis Anjali has decided that it should go to R1? We need to think about it. We need to read about it, maybe in tomorrow's class, right? So let's talk about what is happening at R1. R1 doesn't matter, doesn't see. So this packet now with this data and with this IP address reaches here. What is the IP address? I'm just writing the last 2 octet, 7.100. Although you should understand this is 192.168.7.100. R1 is going to check where this packet wants to go. And interestingly, R1 has made a table that if I'm getting any IP packet and if it wants to go to 192.168.7.0, it should go towards R2. This is what I know. And how this table is built, we are going to learn this in this complete course, right? And this also have another entry that if this packet wants to go to 192.168.10.0, then it should go to R3. So what is going to happen, guys? This packet is going to be received here. This is the destination where it wants to go is 7.100, means it matches this entry. It means that this will go towards R2 and this should not go towards R3. And this is how this intermediate device is taking the decision because it understands the IP address. It is as simple as that, right? Similarly, R2 also knows that where exactly 192.168.7.0 it is saying it is directly connected to me and it is sending this packet to cloud in this network. So try to think your packet is going hop by hop, these devices by these devices, and these devices are known as the routers, guys. We will be introducing these routers in tomorrow's class. Having said that, I would say let's take a pause here today. If you have any doubt, any question, please do ask. Mr. Punish, do we have any question from anybody?
Not in that Q&A. I don't see any.
I think basically Amar Kumar Singh has asked who divides and distribute these IP addresses. And then with subnet addresses and broadcast addresses, the number of hosts in a network remain the same, or will it be two less hosts? Who divides and distribute these IP addresses? Okay. How do we decide if we want to divide network into two parts or four parts? Is there any specific? There are very good questions. We will.
I think probably they might have just chosen you
Huh.
not to host and presenter. That could be the reason
Oh,
in Q&A.
okay.
Could be.
Guys, advertise. The question should go to everybody, right? That is perfectly fine. And I will be taking each and every question one by one now, right? So that we are on the same page. And thank you so much for asking so many good questions, right? So Rachit Puri is saying, will we discuss broadcast addresses at a later stage? We have just discussed. Broadcast address means you want to send a particular message to the entire network. If you want to do that, then use the broadcast address. There is another question from Srishti Dhariwal, and thank you so much, Srishti and Rachit. And she is asking a question that how do we decide if we want to divide network into two parts or four parts? Actually, it depends on the requirements, right? So suppose somebody has given you /24 network, right, which we were talking about. You know that the /24 network contains 256 hosts, and now somebody, maybe your interviewer, is going to ask that and maybe that when you are designing this network, right, you got this IP address and now somebody is saying that boss, we have four networks and each of the four network can contain only 50 hosts, right? Can you do that for me? I do not want this large network. So you must be saying that, okay, I will be dividing this 256 network or the /20 network into four parts. You will get those requirements. Do not worry about it, right? Okay, so if you do not convince with the answer, please do ask the question again. Then basically somebody is asking who divides and distribute these IP addresses, right? So as you know that we have 32-bit IP addresses, right? And this complete TCP/IP protocol was developed in United States. There is a complete organization. The name of the organization is IANA, Internet Authority for Network Assigned Numbers, I believe. Maybe I could be wrong. This is the responsibility of this organization to distribute these IP addresses. And you can know for sure that from 32 bits, we can have 2 to the power 32 IP addresses, right? Huge number. From 0.0.0.0 to 255.255.255.255. And you all know that there can be that there This is a huge number, 2 to the power 34. But believe me, even this number is less. When we started building this internet, right, we were thinking 2 to the power 32 is huge, but it is not. Right now, we are in the shortage of IP addresses. IANA is not providing any IP addresses, but does that mean that I cannot communicate over internet? No, there are some solutions too. If you have heard about the private IP addressing range or the NAT, that is the solution. If you haven't heard about it, do not worry. We are going to learn about it. And that is the problem, right? Because if you consider that networking is this much big, what we have learned till yet is only this piece of information, only this piece. There is still a lot to cover. So to answer your question, there is an organization which divides this. And suppose you have you have your enterprise network. Maybe you are Cisco, and Cisco have 1 lakh people. So Cisco is going to these guys. Can I get 1 lakh? Can I get 1 lakh IP addresses from you? Right? Means if this was the 15, 20 years back, then they would have given you 1 lakh addresses. Even when I joined Cisco, everything is working on the public address range, but not now. It doesn't mean that Cisco doesn't have that range. They have, but they are not using it for their employees. And their solution is the private address range, when we will be discussing about it. But yes, the question is absolutely fantastic. Who divides and distribute these IP addresses? Just talk and read about more on IANA. Then Srishti Dhariwal is asking one more question. With subnet address and broadcast address, number of hosts in the network remains the same, or will it be 2 less than hosts? The question is again great. In normal networking, if we are having /24, then of course the number of hosts are going to be 256. But as you know that we have reserved 2 IP addresses for this, it means that the number of hosts are going to be 256 minus 2, the actual host. But believe me, as you can see that there is a problem with respect to IP addressing. Why to waste even these 2 addresses? These 2 addresses can be used in modern routers. I will showcase you. But for you, yes, you are right that the actual number of hosts, if we do not do anything else, it is going to be the number of hosts, which is 256 for /24 network minus 2. A great question once again. Thank you, Srishti, for that. And then we are getting another question. Who divides and distributes these IP addresses? I think I have just answered it. Thank you so much for your lovely questions. Right? With that, what I have an important announcement also, right, for you guys. So just wait. When I stop the recording, just wait. Okay. So thank you so much. Bye for now. See you tomorrow, 9:30 sharp.